meeting is being recorded to assist with record keeping and perhaps to be broadcast at a later date. If you are unhappy with this, please leave the meeting now. But if everyone is going to stay, thank you everyone for coming. And this is Roy Alexander. He is a director of the Battlesteads Observatory and has been involved with astronomical type events for a number of years. I won't say how many years, Roy. But I'm really glad. I'm really excited that he's here tonight for the end of International Dark Sky Week. So he's going to talk to us about meteors and shooting stars. So my name's Danny. I am the one you've all been emailing. I'm the Dark Sky Officer for Snowdonia National Park, and I work to reduce light pollution across the region, so we're better able to see the stars. I'm not going to talk too much because usually people have got lots of questions for Roy. So rather than me blabber on, I'm going to hand straight over to Roy.
Cool. Thank you very much. Yeah, thanks for having me. I'm just untwiddling some wires here. Probably should have done that before I logged in, but I've only just twiddled my mouse and that's just tangled up. So that's all sorted. Obviously, working from home and presenting from home, I'd love to be able to present to you up at the observatory, but instead you have me, a telescope, some tripods and a tumble dryer. So, you know, that's an essential piece of astronomical equipment there. As Danny said, I've been doing this for quite some time, and more recently, my kind of love of all things space has turned to meteorites. And my degree is in geophysics and planetary physics, and so I really love rocks. I've got lots of rocks in the house, fossils and crystals, and lots and lots of meteorites. Yeah, so I've brought a few to show out of the front room to show you tonight as I do the talk. And I'm going to, in a second, fire up the PowerPoint and talk through that with you. I am more than happy if there are any problems during the PowerPoint or any really pressing questions for Danny to interrupt me with your questions and fire them at me. But obviously, if we could hold them and make a note to the end, that would be better. But I'm happy to hang around for as long as you like. This is a presentation I do regularly at the observatory, but obviously the observatory's been closed for some time, so I haven't done it for a while. I've updated it today and practiced it a little bit, but you'll have to forgive me if I pull up a slide and I go, oh, didn't realize I'd put that one there. But yeah, so let's have some fun. Let's enjoy the evening. And like I said, do feel free to fire questions at me. I've got to share my screen, I think. Where's that share screen? At the bottom. And I'm going to share my PowerPoint. It should be working. And if I do that, that should go into presenter mode. So Danny, can you see that there? Are we all okay? Can we see my PowerPoint? Fantastic. So as you can see, this is the PowerPoint that we normally use when we do Meteor Night at Battlesteads. What I'd like to basically just frame here is that we're going to talk around three really simple kind of overall topics. And like I said, I have brought some space rocks with me, so we'll go through those. But I'm also going to talk a little bit about kind of space exploration and how shooting stars and meteorites tie in with the solar system and so on. So bear with me, and let's see if we can get through it and see if I can remember half of the things I should know about. What I don't do, by the way, is read PowerPoints at you. So it's up there. I'm sorry it's not in Welsh, but my Welsh is very limited to one phrase that Danny taught me the last time we did this. So we're going to look at what are shooting stars. Now, the first thing, obviously, is what they're not. And we often get this question, which is why I'm asking it, which is, are they actual real stars? And of course, they're not. Because stars are enormous. To give you an idea about how big stars are, basically, you could fit 1 million planet Earths inside our sun. So imagine something like that, our sun being a star kind of flying towards us and flying through the atmosphere and being, you know, it just doesn't make sense, does it at all? So in fact, meteor showers begin with comets and asteroids, and most meteorites come from asteroids, in fact. A lot of other meteorites also come from Mars, the planet, and the moon. But shooting stars, which they all are, comets and asteroids. Let's talk a little bit about that. I mean, basically, if you look at comets, and obviously this time last year, we had that fantastic comet Neowise appearing in our skies, which became over the spring, in the late spring and the early summer, naked eye visible. I hope you all saw that. That's it pictured there up at our observatory on the left, taken by, let's see which one took that. Martin took that at the observatory, and that was lovely. And as you can see, it's got this beautiful tail, and that was really visible. Even in kind of towns and cities with light pollution and so on. And comets just have all this material streaming off them as they get closer to the sun. And comets have captured the imagination of people throughout history. And to the point where recently, in the last few decades, we've been able to start exploring them with spaceships. The first one being this, Giotto, a spaceship about the size of a small truck or a large car that we sent to Halley's Comet. Got pretty close, actually, got within 20 odd miles. As we got closer and closer to it, we were able to get much better pictures of what the actual structure of the comet looked like. And you can see all that material pouring off there. More recently, in the last couple of years, we had Rosetta and the little lander, the Philae lander, that went across to Comet 69P, that one there. And we landed on it. So this was like the most detailed picture of a comet taken literally from a spacecraft in orbit around it. And then we were lucky enough to kind of land this wonderful little lander on it, which was actually quite a success, considering that it kind of bounced when it landed a few times and didn't quite make it on the right way up and so on. Didn't land with solar panels working because it was in the shadow of a cliff. So the team had literally 24 hours to kind of test and check what was going on this comet with all of their equipment before the batteries ran out. So, I mean, that was just fantastic bit of science. I remember that vividly. And there's a picture, there we are, from the surface of a comet. And comets are, you may or may not know this, but comets are mainly from the very, very far reaches of the solar system, way out past Pluto, and they kind of orbit around the sun on these really kind of wide and flat elliptical orbits. And as they get closer to the sun, they kind of brighten up, they warm up, and all this material pours off them. Another way to think about what a comet is actually is it's a lot of ice with a bit of rock mixed in. People have often said they're a bit like dirty snowballs. Now, after that, another spaceship that went off to visit a very, very far distant object out past Pluto in the Kuiper Belt was New Horizons. It's about the size of a grand piano there, and it visited this object. Not quite a comet, but still kind of out there and out in that part of the solar system where things are very icy, very rocky, and often come in to kind of visit us, as it were. Other spaceships that we sent to bodies that aren't planets were Hayabusa 2 and Bennu, which went to 2 different asteroids in the asteroid belt and have sampled them. So one of the samples came back last year, December 2020, and this one, OSIRIS-REx, that approached Bennu, is returning his sample in 2023. So these very small asteroids, it turns out that their structure isn't very solid at all. It's really quite mushy, and if you were to try and jump on that and land on that, you would kind of end up kind of sinking into it. So comets and asteroids, okay, that's what we're talking about really, and that's because that's where most shooting stars come from. Comets heat up, and as you can see from some of these wonderful pictures and GIFs, these images from Rosetta as it was orbiting 67P, they do this thing called outgassing. So this is basically the ice being heated up by the sun and sublimating or turning straight into gas. And as it does that, it carries out various bits of rocky material. And all of this stuff, all of this dust from these comets and these asteroids is just left kind of littering space. And that's a really important thing when we come talking about shooting stars and meteorites. So comets break up. They don't just outgas, but they break out. This is the comet Shoemaker-Levy in the 1990s breaking up. And then it hit Jupiter. So that was quite impressive. Just to get an idea about how big those impact blotches are, there's 1, 2, 3, 4, 5 dark spots along the southern part of the southern hemisphere of Jupiter. That red spot there is about 2 to 3 times as big as planet Earth. So probably really good that that didn't hit us, actually. So I'd just like to include this slide just to give you an idea about where these objects are coming from. So when we have meteorites, when we see shooting stars, these are objects that either are coming from the asteroid belt, which is between Mars and Jupiter. So you see there the planets Mars and Jupiter there, or they come from the Oort cloud, which is this hypothesized spherical shell of these icy, dirty snowballs, these comets that come in and visit us. And all the time, these things are distributing dust and gas throughout our solar system as they kind of break up, as they outgas and so on. Asteroids are really cool, actually. So some asteroids are big enough to be minor planets. So, for example, Ceres is quite large. Ceres is a big asteroid that in total constitutes about 1/3 of all of the mass in the asteroid belt. It's quite large. In fact, there was a point of time, I think, in Victorian times, and it was considered to be big enough and cool enough to be a planet. Okay. Now, normally, all the meteor showers that you'll see in the year are from comets, but these ones here, the quadrantids, and I can't quite see what they're. I think it's the Ursids, come from asteroids. There's an asteroid just like a comet breaking up, and the important thing here to remember and to think about is that as all of this stellar material, this cometary dust, this asteroidal dust, is breaking up and littering our solar system, sometimes the orbit of the Earth coincides with this debris field, and sometimes these debris fields continue on in their orbit, like they follow the comet's tail, as it were. The comets and asteroids, they leave these dust trails suspended in space, and then the Earth slams into them at high speed, and that's when you see your shooting stars. And that's why you see, like we had the Winchcombe meteorite a couple of weeks back, kind of flaring up so brightly that you can see them even during the day, because the velocity that the Earth is traveling at compared to the velocity of the debris is huge. We're talking usually about tens of thousands of miles per hour. And that's why you get the shooting stars. Okay. So how easy is it to spot shooting stars? Well, the first thing that you need to know is that meteor showers are named after the constellation that they appear to come from. And that point is called the radiant. So here I've got a screenshot from one of my favorite free pieces of software, Stellarium. If you haven't got Stellarium on your computers or your laptops or your phones, it's really worthwhile getting. I find that it's better on your computers than it is on your phones. Personally, there are better ones for your phones, but it's still not bad. And it's completely free, and you can set it to where your location is and go forward and backwards in times, and you can look for these little yellow starry splodges on the screen, and that shows you, excuse me, the radiant of that particular meteor shower or shooting star shower. So for this one, for example, the Perseids, which will be the next really kind of big one for this year. There's a couple coming up in the summer, in May and July, but they're not that brilliant. This one is August the 12th, usually, almost kind of like religiously every single year. And the Perseids come from the constellation of Perseus. They appear to come from that constellation. So why, if we are traveling through this stream of dust and dirt like that, do they appear to streak towards us, almost like Han Solo and Princess Leia flying the Millennium Falcon at light speed? Well, that's an optical illusion, a bit like sunbeams, crepuscular rays that kind of shine through clouds. If you see them from space, they look like perfectly straight lines, just like meteors when they fly through the atmosphere. Shooting stars do it in perfectly straight lines, but because you are traveling through on planet Earth through that shooting star kind of mass of dust and ice, it looks like that kind of picture that you see there. That's obviously someone driving through a snowstorm, so it's kind of a similar physics. Okie dokie. So meteorites. Let's talk about meteorites now that I've given you a bit of an introduction into the whole shooting stars, from where do they come from, and where do they originate. Well, so there's some terminology to think about here, and for those of you that are quite happy to read ahead, then you can see up there. But we do talk about falls and finds when we're looking for meteorites. Meteorites being the name that we give to the space rocks that actually land on Earth, that make it through. They don't fully burn up. They land and you can find them. If you see it, if it's on your CCTV, if you're out on a daytime, if it's on your dash cam and you see this thing flying through space, then that's a fall. And they're much, much rarer than a find. Finds are quite common in terms of, you know, how we find these meteorites, how we find these shooting stars. You've got a couple up there, the main one being Chelyabinsk. I've got a piece of the Chelyabinsk meteorite here, which we'll show you in a second. That was 2013, and until recently, that was kind of like the biggest meteorite fall in modern times. It's lovely actually, because you can look at a piece of the Chelyabinsk meteorite, which again I will show you in a second, and the insides of it are still beautiful and grey and pristine compared to all the meteorites, which are a bit more brown and a bit kind of more rusty. So yeah, let's look at that Chelyabinsk meteorite. Some fairly massive kind of amounts of energy. This huge kind of meteorite, 20 meters in diameter, so it would easily kind of, from a diameter point of view, just barely fit inside a swimming pool from, you know, if you were going to swim a length. But the important thing to think about here is it did blow up about 18 to 20 miles up in the sky. And it did so, they reckon, with the energy of about 30 times the nuclear bomb that so ruthlessly destroyed Hiroshima. Imagine that kind of object getting closer to the Earth and then exploding and the devastation it would cause. Now, luckily, it didn't cause much destruction, but about 1,500 people were injured, mainly from things like broken glass, because there was a sonic boom, which, you know, and explosions, which kind of sent shockwaves through the atmosphere, shattering glass, and people getting kind of cut from that. But it's actually quite a common meteorite to be able to buy, a Stoney meteorite, because so far over 100 kilograms has actually been recovered from people who live in and around the area. And if you're really lucky, you can find people who have found bits of meteorite. They'll find them even now. They're up in their attic. They haven't been up in their attic for nearly 10 years. They're looking for something, or an old shed at the bottom of the garden. They're doing a tidy out, and they might find a small hole in the roof or something, and there it is, a meteorite that's been sitting there for a few years. One of my friends has a piece of meteorite that landed in someone's greenhouse. And he didn't just buy the meteorite, he bought bits of glass that the meteorite broke as well, and has a picture from the guy who found it in his greenhouse. He took a picture where it was. But things like that are really fantastic and really interesting to own because they have a story. A very quick graph here. I mean, I'm not a big fan of graphs and formulas and maths and equations in these kinds of presentations, but what I do like to show here is that we don't have to worry about 10-kilometer plus, you know, these big meteorites that destroyed the dinosaurs hitting on a fairly regular basis. If you can look down there in that very bottom red part of that triangle, that doesn't happen very often at all. The I can never say this properly, the Chicxulub impact meteorite, which we think was somewhere between 20 and 50 miles wide. I mean, that was huge. And it wiped out the dinosaurs. Well, it wiped out pretty much everything, actually. Chelyabinsk, a bit smaller. If you go up there, somewhere in the middle of the graph, it's about every 100 years something as big as Chelyabinsk will fall. But I will, if you go right up to the top of the graph there and look at the 1 micron diameter down to 1 millimeter diameter, these are things called micrometeorites. Now, we're going to talk about them a little bit because you can collect micrometeorites in your own backyard, okay? And they fall quite frequently. They are difficult to find, though, mind you. Need to talk about needle in a haystack, but we will talk about that shortly. Right, so not so much a graph, but a nice little diagram. How often do meteorites hit? We've just talked about. Where do they hit? So here's a diagram that shows 30 years worth of meteorite impacts. And as you can see, they're pretty much falling all over planet Earth. Obviously, our planet is mostly water, so most of those meteorites are lost to the sea. You might be asking yourself, well, how does this graph work? How do we know these meteorites have hit the Earth if they've landed in the sea? How have they been recovered? Well, actually, this isn't that. This is like almost like a graph of not of finds or falls, but of something else. This is CNEOS and NASA basically can detect when fireballs explode in the sky, when these bolides create these huge big fireball shooting stars, and that's what that is. And there, I couldn't believe that picture there, the Winchcombe meteorite, I think that's right, the Winchcombe meteorite, a very rare carbonaceous chondrite meteorite. Now that's a word that really plays havoc with my dyslexia, because I want to call it a chondrite, but it's not. It's chondrite meteorite. These are very, very old objects. I mean, the oldest rocks you'll ever find on Earth are about 3 billion years old, and all meteorites are pretty much older than that, unless they come from the moon or Mars. But these ones, this one that landed in Winchcombe, these are the oldest. These are over 4.6 billion years old. They are very, as you can see from that picture, very crumbly and very fragile. They break up really, really easily. And they're very rare. They are literally objects that were around at the start of the solar system, when the sun first sprung into life and burst into life. And they are objects that weren't big enough for gravity to do anything to their internal structure. They didn't collide with anything else in space and kind of clump together to form moons and planets like everything else did. They just, these little small objects in space, and they've been there for 4.6 billion years. So these kinds of meteorites tell us a lot about what the early solar system was like. And because they're very rare, because they break up really easily, they're incredibly valuable. And when I found out that there was 40 odd grams of this stuff, and that not only that, but it was kind of pristine carbonaceous chondrite, and the people in the house had just given it away for free, I was astonished, because the value of this object is 6 figures. So, you know, that's the other thing about meteorites. If they land in your back garden, it is money from space. It's free money. So meteorites don't just fall on the Earth. We've got a record of about half a dozen meteorites being seen on planet Mars. And over the last few years, as more and more amateur astronomers image the moon, we're seeing impacts as they happen in those videos on the moon. So a couple of GIFs to the right of my screen, I'm assuming it's also the right of your screen there, where you can see arrows pointing to little flashes that are impacts of various objects hitting the moon. And the one in the bottom left is a before and after. This object here, I think it's called Big Bertha. It's a fascinating object. This is an Apollo moon sample brought back by the astronauts, and it's got a piece of planet Earth embedded in it. So this is a piece of the planet Earth that must have been flying around in space from back, 3-4 billion years ago, when we had this huge heavy bombardment of comets and asteroids and God knows what flying around the solar system and hitting the Earth and so on, blasting bits of the Earth off out into space. One of those bits of Earth landed on the moon, got embedded in this piece of moon rock, and then the Apollo astronauts brought that back. So, I mean, I just think that's astonishing. So I am going to talk, we're getting very much closer to looking at meteorites. I'm just looking at the time, 7:30, so that's good. I know I'm talking very, very quickly, but I'm really happy to revisit any of these points in the questions. And the key thing here is that when meteorites do burn up in the atmosphere, they sometimes have different color expressions. The main one being that Perseid meteors often can be very green. And basically, just like fireworks, the colors that you see when they go off or when they burn up are related to the chemicals that you find inside the rocks. So there are people out there, even amateurs now, who have equipment that will image the sky and video the sky for a period of time. And when a shooting star cuts across the viewfinder of the camera, they will take the spectrum, they'll analyze the range of colors that are coming from that fireball, the spectrum, if you like, because they give off like a little rainbow. And the colors and the amount of color that's in that flare that you see tell you something about what's in that meteor. So it's great to have meteorites. Remember, the word meteorite means they've hit the ground. It's great to have a meteorite so we can look at them in the laboratory and see what they're made of, and that tells us something about what perhaps what we're made from and where we've come from. But they don't have to. We don't have to have them in our hands. We can see from the light as they burn up in space, in our atmosphere, in the very high reaches of our atmosphere. We can see from that light what they're made from. So there's a lot of science around meteorites and shooting stars as well. So let's talk about collecting them. Right, well, what are you going to want to do if you want to collect meteorites, and how are you going to collect meteorites, and how do you know if you're going to collect them, if you're going to buy them, if you've got a meteorite or an earth rock that looks a bit like a meteorite? So, is it a meteorite or is it a meteor wrong? And well, luckily, thanks to the wonders of social media, Facebook has a group called Meteorite or Meteor Wrong. So the first thing you could do, if you find a rock and you think it's a meteorite, take a few pictures of it, post it on there, and 99 times out of 100, people get told that it's an earth rock. So do be prepared for disappointment. But it's exciting, science is all about lots and lots of no's before you have that eureka moment. But if you do find a meteorite, it's going to be one of three different types. You either have your rocky meteorites, or your iron meteorites, or you have something that's a blend of the two, and that you've got some examples up there. So you'll see, actually, there's a couple on the right. The one at the top right-hand corner is quite rusted. They're very much more metallic. The one in the middle with the crystals in it, that's rock, olivine crystals. I've got one of those here to show you in a second. And on the bottom left, you've got the much more kind of rockier meteorites as well. And they do fall into those three categories mainly. No, they do fall into those two categories. I don't know why I say mainly. There aren't any other meteorites, I don't know, made of fish or cake or anything. They are either stone iron or stony iron. Within the category of stone, though, this is where I do sometimes get myself a little bit mixed up. Within the category of stone meteorites, you also have Mars meteorites and moon rock meteorites. They fall within that category. So, right, let's say you've got a lovely iron meteorite. Where has that come from? But if you can imagine looking at a great big asteroid floating out there in space in the asteroid belt, if it's big enough, then as that asteroid formed, it's very, very hot, because basically asteroids and planets all form out of collisions of material orbiting around the sun, rocks and metal and goodness knows what else, smashing together. And sometimes they smash together and stick. And that produces a lot of heat, that process. There's also kind of radioactive materials out there as well in our Earth and in asteroids that produce heat too. So you end up with, let's say 4.5 billion years ago, you end up with these objects, so 4 to 4.5 billion years ago, you end up with these objects like planet Earth that are very hot, very molten, and they're very large. And what happens, because they're so large, the force of gravity is strong enough to really start pulling on the heavier metals and elements within that hot primordial asteroid, if you like. And the iron sinks to the middle. Gravity pulls all the iron, most of it, to the middle of that object. And you end up with, like the Earth has, an iron core. So out in space, this would have happened to a lot of different kind of asteroids and so on, a lot of the bigger ones out there. And then, perhaps looking at this wonderful object, if you were out there 4 billion years ago with your spaceship watching, you might have seen two of these objects collide with each other and break up. And when they do that, bits of the core, now frozen and long dead, go flying off through space. Bits of the stony mantle go flying off through space. So when you pick up an iron meteorite, if you buy an iron meteorite, and you can buy them relatively inexpensively, you are holding an object that definitively, absolutely was once the molten, broiling heart of a dwarf planet or a small asteroid. And I love that idea. Anytime you hold an iron meteorite in your hands, that's what you're doing, okay? More kind of rocky meteorites, which can have a little bit of iron in them. So when I show you my meteorites, when I turn my presentation off and show you, I'll stick magnets on them. And they do have an iron content, but it's quite low. Stone meteorites tend to come from the mantle of asteroids. Now, I'm going to stop here and very quickly mention that before I talked about the Winchcombe meteorite being a stone meteorite. It was pristine and came from much, much smaller objects in space. And that's different to this kind of object here, a rocky meteorite that's come from the mantle of a planet like Mars or an asteroid. Because when you get planets form, when you get your large asteroids form, when the iron sinks to the core and you get other stuff going on like volcanoes, or on Earth we have tectonic plates and volcanoes and earthquakes. These are all kind of ways that rock gets heated and changed. So there are no, say this right, chondrules in that rock anymore. They all get kind of melted out. You ended up with a kind of like an igneous heated rock. And the objects that they come from, so the Earth, the Moon, these asteroids that have a definitive core and then a mantle around it and a crust over the top, we call those differentiated. They're not the same all the way through. And a nice comparison here, some of you might be old enough to remember when you could buy milk with the cream on the top. In fact, all milk had the cream on the top. And that's an example of a differentiated fluid. You've got the normal milk at the bottom and the cream at the top. They've differentiated out. Nowadays, when you get milk and you buy it in the cartons, it's homogeneous or homogenized because the cream is blended through. So your iron meteorites, your stony meteorites, and your parasites, which is this kind of meteorite, all come from differentiated objects like asteroids. And parasites are beautiful. Very interestingly, in the last year or so, the origin of parasites has come into dispute. I nearly said disrepute there. Has come into dispute. So originally, scientists, well, we thought that, you know, given that parasites are iron meteorites, this lattice of iron with olivine crystals and rocky crystals kind of scattered through them in the matrix, that led us to really believe or hypothesize that parasites came from the boundary layer of an asteroid between the metallic core and the stony mantle. I mean, that makes sense, right? If you think about it, if they're mixing together while the asteroid is still quite hot and then molten and they're mixing together, at some point in that asteroid's life, it's going to cool down, that everything's going to solidify, and where they're mixing together is going to solidify out and you're going to get crystals and iron interwoven. Wonderful, of course, it makes sense. But the last year or two, there's been some research to suggest that parasites come from large collisions where perhaps the iron and the mantle get mixed together as they are ejected from the object. So that's kind of a watch this space bit of science there. Parasites are quite rare. So when you buy them, when you own them, you end up having to generally get very, very thin slices. So I'm going to stop sharing my screen right now, but I'm going to come back to this. And I'm going to turn the light on that's above me. So we're a bit brighter in here. And we're going to show some meteorites. But I thought, Danny, are there any really burning questions that we wanted to answer? Danny?
Sorry, my video wouldn't come back on then.
Well, I can see you.
Yeah, well, that's good. We had one which is from Martin, and he said, "Hi Roy, do we not call them meteoroids anymore? Is it now?"
I'm not sure about what the etymology of the word meteoroid is, actually. I used to know that off the top of my head, but I would suggest let's Google that and find out. No, so I mean, I think a meteoroid is what a meteorite is called when it's in space before it's fallen down. I'm going to Google it. Meteoroid. But a meteoroid is a small rocky or metallic body in outer space. They are significantly smaller than asteroids. Yes, okay. So that's a good question, bringing up some terminology, Martin. So a meteoroid is, I guess, then essentially a good way to think about that is what either a meteor or meteorite would be if it didn't come from an asteroid and was just an object floating around in space, kind of ready to come through the atmosphere and be a shooting star and land or so on.
Just for everyone to know as well, if you do want to ask a question, feel free to unmute yourself, if that's the easiest thing. But also, wiggle your mouse on the screen. There is a chat. Looks like a little speech bubble. You click that and you'll be able to type to everyone, just in case you don't know. I have a question, Roy.
Go on then.
if you found a meteor and you say they're worth a lot of money, which I didn't realize, who buys them?
Me, people like me. But you know what I'm going to do? And I'm going to use this as a teachable moment, Danny, and I hope you don't mind, just to correct your terminology. So you said, if I find a meteor.
Oh, sorry, a meteorite.
Yes, there you go. So I
Sorry,
wouldn't
I
find a
was
meteor
listening.
because they burn up in space. So meteorites hit the ground. It's
Well, you,
almost like we practiced that, isn't it?
you fell for my trick because I was just, I was just testing you, really.
Yeah. Okay, so this is the bit where I'm going to try and show you my meteorites on my camera. I have just recently bought an HD 4K camera, so this should work really well. But we were trying this before, Danny, weren't we? And the focus wasn't particularly great, but we'll see.
Oh, we just had a quick question, though, as well, from Tracy. Have you ever gone meteorite hunting yourself?
No, I haven't, because largely meteorites don't fall in the UK. So, and you know, I've got kids and a family, and I've never really had the opportunity to go off to Africa or Arizona on my own and spend days trawling through the deserts looking for them. But I will do, and I hope to one day. Micrometeorites I have done. So when I put the presentation back on, we talk about micrometeorites. I have done that, and that's interesting. I have very
small percentage of meteorites that fall in the UK, considering we're such a small country. For two to have fallen in the last month or however many it is, that must be a really slim statistics.
It is, and I'm hoping they find a piece of this other meteorite, and I'm hoping that it's a chemical match for the Winchcombe one, because that would kind of give some credibility to my idea, which is that maybe we're kind of passing through a new cloud of debris that we haven't previously discovered. That kind of stuff happens all the time.
Why we've had two? Is there is there potentially a reason out there in space that they seem to be quite regular at the moment, with some around the world?
Yeah, I mean, part of that is largely because everybody's now walking around with an HD camera in their hands, pretty much. You know, even in low and middle income countries, having a mobile phone with a camera in it is still something that most people have. A lot of people have, you know. And people have dash cams on their cars, they have these doorbells with cameras on them, and so on and so on. So we're seeing more. I don't think that more are falling. I just think that we're getting better at spotting them and seeing them. And I think in the last couple of months, that's coincided with people being really keen meteorite hunters. So a friend of mine who I've bought a couple of these meteorites from, his name's Graham Ensor. He has a meteorite collection worth tens of thousands of pounds, and it rivals any museum. In fact, museums buy meteorites from him. He has spent a fair bit of time traveling around the world looking for them. And I'd love to do that, but I think it's something I have to do when my kids are all grown up and have moved out. Give me a bit of time. Yeah, so I can see I've got the questions now. I've just opened the chat, Danny, so I can see that there. Right, so here we go. First, this is a Stoney iron meteorite, but mainly a Stoney one. How's that looking so far? Can we see that, Danny? Yeah. Now, so you can see it's quite obviously a rock, but what's going on with the rock? There are some parts of it that look quite, you can see the granularity of it, and it's quite kind of gray. There's a shiny little bit in there, and I'm going to stick a magnet on that. Look, whoops, I'll drop the magnet under my keyboard first, because obviously that's going to be really helpful. Well done, Roy. Got some teeny tiny rare earth magnets, and if I stick one to that, look at that, the magnets stick. So that's an actual little kind of streak of iron running through the meteorite. That's quite rare. If I put the magnet on a rocky part, this blackened kind of outer layer, which we'll talk about in a second, is still sticks, but not quite as strongly. Now, this black outer layer is called a fusion crust. So as this meteorite came flying through the air, as it was in its brief life as a shooting star, the heat produced by that process melted the outer layer and coated it with this kind of this dark black, which when it lands actually is very rough, like sandpaper, and it is very black usually. So what I'm going to do is maybe compare that with this one, my Chelyabinsk meteorite. So you can see this is the older one, this is the newer one. The newer one is blacker because it's fresher. Is that apparent, Danny? Cool. This here is the internal structure of the meteorite. Because there's iron there, iron in there, it's rusted over time. It's also got dirty from being handed round. And can you see that's the internals of the Chelyabinsk meteorite? It's much more pristine, it's grayer. But I don't know if you can see, is my camera picking up the little orange spots in there? I'll get really close to see what happens if I do that.
Oh yeah, it is, yeah. I'm going to see if I can make you bigger for everyone. Hang on.
Oh, look, that's what you do. Do you see that? If I make the whole screen, if I cover my whole screen up, then it plays with the autofocus. How's that? That's good, isn't it? Look at that. So those little orange spots, when I first got this meteorite 2 or so years after their fall, they weren't there. You know, well, the iron was there, but the orange spots weren't there. But in the few years it's been in my house, exposed to the humid air of Gateshead and Northumberland, that iron has rusted over time.
That's
and then
cool.
you've got those orange spots.
Just for everyone else. I think I've changed it for everyone, but if not, if you go and wiggle your mouse on your screen, there's a little box in the top right-hand corner that says view, and you can click on speaker view and it will make Roy bigger so you can see his meteorites bigger.
Yeah, I mean, you don't want to see me bigger, but seeing the meteorites bigger is a good thing. Now, so there's your rocky meteorites. There's 2 examples there of a normal generic one. Something like that might cost you 10, 20 or 30 pounds, by the way, from a meteorite shop. The Chelyabinsk ones, they're smaller, same amount of money for a smaller one. Now I'm going to put those out of the way so I don't get confused. Get them back out again. Now, you know, I talked about when you hold an iron meteorite in your hand, you're holding something that was once the hot, molten, broiling core of a meteoroid, not of a meteoroid, of an asteroid or a dwarf planet. That's what this is. Now, this, when I first got it, had a lot of dark black kind of coating all over it, which is a kind of a fusion crust and a bit of rust. But this gets handed around at the observatory a lot, so it's been kind of polished and worn away with time. That's a 2 kilogram lump of iron. It's about 95% iron and about 4 and a bit percent nickel and some other bits and bobs. Excuse me. And that used to be part of the core of a large differentiated object from space. And one of the features of things like this, these iron meteorites, is as they come through the atmosphere and they're traveling at super high speeds, little whirlwinds, little eddies of hot gas appear on the surface of the meteorite and kind of melt out and focus energy, if you like, into these points and melt out the material, and you get these thumbprint type indentations like that. They're called regmaglyphs. And that's one feature of an iron meteorite, and you can kind of see them all over, these little thumbprint like indentations as it's flown through the atmosphere, and all these little hot whirlwinds and mini eddies have appeared around it. That's 2 kilograms, so I'm going to put that down. Oh, it's quite heavy. Now, parasites. We talked about parasites, and I talked about how they're very rare and very valuable because they come from, we think, that boundary layer between the iron core and the mantle. So you tend to only buy them in slices like this. So this is a very thin slice. It's about 2 millimeters thick, but it's a nice big slice. Can you see my camera is reflected? Because when people slice these, they polish them into a mirror-like surface. But that's basically, if I can get it at the right kind of angle so you can't see reflections, it doesn't anything that's possible. Reflect the ceiling. The ceiling's probably a little bit more bland. There we go. So that's iron with your olivine crystals in, and there's one there up there which is practically transparent. That olivine crystal there in that corner. And I'm just going to demonstrate with the light of my mobile phone how clear these crystals are. Olivine, when you get it gem quality, is peridot or peridot, which is the birthstone for August. Any Virgos out there? If you're a Virgo, you love meteorites. That's apparently the thing. So look at that. If I put my torch behind that from my mobile phone, can you see it shining through the crystals? Some of those crystals, you know, when I hand this out at the observatory, and people look through these. You can actually look through them. They're almost lens-like in their quality. And there are people, I don't know why they would do this, but there are people that buy these meteorites and then try and kind of mine the crystals out, if you like, to put them in jewelry. That's very expensive jewelry. You can buy a small, say, kind of 1 inch by ½ inch slice of a parasite like that for about 50 to 100 quid. So if you did want to own one, they are quite expensive, but it is possible. If you wanted to own an iron meteorite, you can get a small piece like this. This is just a few grams, and you can buy these for 10 or 20 pounds. And I'm going to type the name of that meteorite in the chat, and it's basically a Campo de Cielo, and they were discovered in Argentina a few hundred years ago. And the reason I'm going to do that for you is because if you want to start off owning meteorites, you know, and space rocks and things like that, buying yourself a Campo de Cielo from a reputable company is a really good little idea. It's a good way to get started. The final meteorite I'm going to show you tonight is this one. This is a rocky, a chondrite meteorite that basically comes from the surface of our moon. This is a moon rock. Okay, so we'll try and hold this up nice and close again. If I can force the focus to, oh, look at that, I've got it. So the orange stuff in there is the sand from the desert that it was found in northwest Africa. One of the countries beginning with M. Mauritania, I can't remember. But the interesting thing about this is that the lighter and the darker rocks are essentially the same as you find on the moon. When you look up at the moon and you see the dark patches of the moon, that's more of a kind of a basalt type rock, and you look at the gray stuff, that's the light gray, that's more of a feldspar type rock. That's what you've got here. Now, we had this one out at the observatory, and this is a fall that was, no, it's a find, it's not a fall, it was discovered, it was a find that Graham Ensor managed to negotiate purchasing directly from the African dealer. And Graham bought 1.5 kilos of this. And there are no other pieces of this particular meteorite in existence anywhere on the planet. So when I bought this one from Graham, I bought it as a generic lunar meteorite. It's 34 grams. It cost me less than £1,000 actually, which is not bad for a lunar meteorite. But then when it got classified as part of only 1.5 kilos of lunar melt breccia, which is what this is, that value went up quite considerably overnight, to the point where I actually have this insured now. But I still hand it out at the observatory, and every now and then have to clean it. And when we look at it closely with a magnifying glass, it has a few really tiny little olivine crystals in it that sparkle and twinkle. And through one of these, the lighter, that one there, you probably won't be able to see it, but through that big one there, if I can get it to focus in, I can trick the autofocus, there's a shock line that runs through that. I can't get it to do it, it's not going to do it now.
Oh, Roy, Tracy's asked, what's your favourite meteorite and why? Is it the one you're holding now?
Oh, I don't know. I'll have to come back to that, actually. Now, there are two answers to that, Tracy. It's what's my favourite meteorite that exists and what's my favourite meteorite that I own. So I'll give you an answer to both of those in a second. I'm having to think about that. I do love, I've got a piece of planet Mars as well somewhere in the house. I couldn't find it in time to show you lot, but it's tiny anyway, because Mars meteorites are stupendously expensive. And for a couple of £100, I was able to buy something the size of a large pea. It's in a box. Meteorite
happened. Would it be something that would collide with Mars? That's
yeah.
Out, and it would just come to here.
Yeah. So yeah, exactly. So basically, object in space, Earth, Mars, the moon. Something hits it, and imagine stamping in a puddle. You know, when you stamp in a puddle, water splashes out from that puddle, doesn't it? Some of it lands back down, and some of it goes so high up it might stick to your jeans or your dress or your shoes or whatever. It's the same thing when things hit Earth. When things hit Earth, or they hit Mars, or they hit the moon, a lot of that material falls back. If you're looking at the moon overnight time and it's a full moon, in the bottom right-hand part of the moon, you can see this crater that almost looks like a star on the surface of the moon. It's called Tycho, this crater. And it's quite it's quite a recent meteorite impact. And that sprayed a lot of material across the whole surface of like about a third of the moon. Some of that material would have been blasted into space at escape velocity faster than gravity could try and hold it back. And that stuff then floats around out there in space. There's lots of it up there. And every now and then our tiny little blue dot, our little marble called Earth, flies through that and it lands. Now, part of the reason as well why I haven't gone meteorite hunting in England is because, well, one of the chief constituents of meteorites is iron. And what does iron do in wet, miserable, cold countries like England? It rusts away to nothing. So meteorites like this one, Campo de Cielo, that's found in the Argentinian desert. It was there for 5,000 years. Nothing happened to it. This parasite, Semchan, in a dried up Russian riverbed, dried up, still, still not rusted. It's got a bit of a spot of rust on it developing now, actually. Every now and then I have to clean it. But meteorites that fall anywhere on Earth where it's even a little bit humid, unless you see it happen like they did with that Winchcombe one, they either get washed away in the rain or the iron in them dissolves away, and then they get so weathered they just become stones and rocks on the ground, or they become part of the Earth.
When people look for meteorites, how do they know that it's a genuine meteorite? Who would they go to get it tested?
Okay, so let's just answer Tracy's questions first. So I think that my favorite meteorite is my moon meteorite. It sits on my desk and I could just pick it up and I'm holding a piece of the moon in my hands and I love it. I think my favorite meteorite that I know that exists, I must say now, it's probably going to have to be this new one, this Winchcombe meteorite. I really like the sound of that, and I like the look of it. I like the story around it, how it was found. It's a carbonaceous chondrite, so it's going to have information in it about minerals and material left over from the beginning of the solar system, and it's beautiful. I love the blackness and the darkness of it. It's great. How can you find a meteorite? Well, the first thing, if you think you found a meteorite, is magnets tend to stick to them. Unfortunately, they don't tend to stick to the moon rocks. The moon rocks have the ions basically wrapped up chemically with other stuff, so it's not magnetic anymore. But with other meteorites like this one, you stick a magnet on it. And if a magnet sticks to it, that's your first hint that it's a meteorite. The second thing is the outer surface of it will be in some way blackened. Let's see if I can get this to focus on this one, because we didn't do that. Come on, camera, you can do it. There we go. So that's the inside of it. But if you look there, especially on that corner where a bit of that fusion crust is chipped off. There we are. Oh, there we go. That fusion crust is a 100% guaranteed bit of evidence that you've got a meteorite. And the fresher that is, the blacker and the rougher that will be. Now, apart from that, you've got other features like we talked about, those kind of thumbprints. But once you've kind of seen those easily identifiable features, what you tend to have to do is slice a little bit off or use your Dremel, because I've actually polished a bit of that off on there. I just wanted to see what it was like inside, so I got my Dremel and I polished a little bit off, and you can see the internal structure. So if you end up with something like this Chelyabinsk one that's got this kind of internal structure to it, come on, there you go. Very grey, rocky material with these little dots and spots in it, or even better, if it's got these chondrules, which are like little kind of pristine, untouched grains of sand, then you know that's definitely a meteorite. But at that point, that's when you send it off. You either take pictures and put it on the Meteorite or Meteorong website, or you send it off to one of the people who work for example, the University of Manchester or the Open University in the meteorite department. There's always people you can reach out to, and universities are the best place to go. Okay, back to sharing the screen. Let's see if this works. Okay, so we've done that. That was fine. We did that. Did that. Tektites. Right. If you were to buy meteorites, I tend to buy all my meteorites now from this company, MSG Meteorites. There are other companies out there. You can go on eBay. eBay is a nightmare for buying meteorites. I've seen people put bits of sandstone and granite and basalt on and selling them for thousands of pounds. And eBay has no way of differentiating them from actual meteorites. So there are lots and lots of people out there on eBay buying rocks that are earth rocks that aren't meteorites. So just don't do it unless you go through a reputable website like MSG Meteorites. He does list his stuff, some of it on eBay. You've got the meteorite hunter people as well, although they tend to be quite expensive. But there's also groups. So this one here, meteorites, tektites, impactites, and ephemera. There are often people selling meteorites on there as well. And back in the old days, before Facebook, if you wanted to buy a meteorite, you'd have to buy them from a dealer. Nowadays, the Bedouin and the nomads and the people in the deserts of Africa who are finding these rocks have Facebook pages and regularly will sell them on. You can just buy them direct from the dealer. There was a fall in Libya a couple of years ago, and there was a video where someone had just driven up with their 4x4 flatbed truck, put a blanket in the back, and they were tossing lumps of this meteorite that they'd found, just throwing them in willy-nilly. I mean, there was so much of it, so much of the material, that it wasn't that horrific to watch, but it was horrific. It was like, oh my God, can you please be careful? But you can buy these things directly from these people. But what if you want to collect them yourself in Britain? Well, this is when we are looking in the realms of micrometeorites or micrometeoroids. There we go. Actually, I do have micrometeoroids in this presentation. So these are tiny. The biggest micrometeorites you'll see might be 1.5 millimeters across. The smallest ones will be so small that you have to use a microscope to see them. On the left, you've got there, basically, this is a piece of gel that's come off an aircraft that I think NASA use from time to time. They fly this aircraft just through the upper atmosphere with gel on some of the leading edges of the wings. And as they fly into particulates, micrometeorites and dust and so on, it impacts into the gel. And you can imagine the heavier ones go further in. They get them back to the lab, they take them out to gel and they examine them. And micrometeorites are wonderful and fantastic things, but if you're an astronaut, they're not. They're quite terrifying because especially actually a lot of kind of space debris that's orbiting around us now, these micrometeorites are human, they're man-made. They come from satellites breaking up and so on. There was a near miss last night. 2 satellites almost crashed into each other last night. And those of us who kind of know about this thing were watching it on Twitter, and it was terrifyingly close. It would have produced hundreds upon hundreds of fragments bigger than 20 centimeters, let alone all the smaller bits. But micrometeorites in space fly so quickly they can blast. So, for example, there's a finger of an astronaut pointing to a hole in the window of the cupola. Handrails, which is terrible if you're shuffling along in a spacewalk, an EVA, and you catch, your spacesuit or your glove on a little burr. And frequently, the space shuttle had to be examined for micrometeorite impacts as well. But there, if you want to collect micrometeorites, if you can, what's the best way to say this? If you've got a lot of patience, and you probably need a little microscope as well, maybe a toy microscope, or you can buy like entry-level school lab microscopes for about 40-50 quid. There's plenty of stuff online for you to have a look at, and I'm going to summarize some of that now so you've got a rough idea. It's 8 o'clock, Danny. I can carry on for a few more minutes and tie this up. But if you need to,
I think you can tie it up. I want to know how I find stardust in my
In Search of Stardust. Well, if you look at the name there on that book, John Larson, he's got a Facebook page, he's got a website, and he's got Twitter. So do follow him. And he's brought out 2 or 3. Actually, even if you don't like the idea of meteorites and space rocks and collecting them, the books he's produced are beautiful kind of coffee table books. And they give you an idea about how to hunt for these teeny tiny space rocks in your garden or in your guttering. Actually, a number of different ways to look for them are, so that's actually a baking tray I left out in my garden for a week with some cling film on it. and you collect the debris from that. You can put a bucket, either just drop a bucket at the end of your guttering, or like some enterprising young scientist has there, she's put something there on a drain to kind of collect micrometeorites. As the water runs through, there's a magnet in there, and the bottom of that, as the sludge is collected. This person here on the bottom right, I think that comes from John Larson's book, actually. A very strong meteorite inside a baggie. And then basically you run that meteorite through your guttering or on your roof, or if you've got a large commercial, huge commercial building, and you can sweep up all the dust and debris on your roof or whatever, and then run that magnet through and you collect it up. When I saw that bag there, the one about with the magnet in a bag on a beach, all I could think of there was, every time we're getting a dog soon, every time I get a dog to the beach, the dog to the beach, I'm going to put a magnet in a bag around its neck on its leash so it's safe, and allow it to kind of drag that through the sand as it runs around, kind of collecting micrometeorites for me. Now, what you've then got to do is you've got to dry them off, and you've got to then get out all of the part of my language, the crap that isn't micrometeorites. And the best way to do that is to use proper filters, like micromesh filters that you can buy off Amazon or scientific websites. Actually, I bought a coffee filter the other day to try this with, a very fine micromesh coffee filter. And you basically, once you've dried the material you've collected, you pour it through these micromesh filters, and you're left with what that person has there in their hands, this very, very dry, fine kind of bunch of material. Now, looking there, you're probably only going to have in that handful of material there, you're probably only going to have between 5 and 10 micrometeorites. So these are all magnetic, and the next thing to do is to try and recognize them as a micrometeorite. Now, a couple hundred years ago, this chap, Lucien Rideau, found loads of metal particulates in material he collected, and sketched them. And in that particular sketch there, I can see what looks like possibly 2 micrometeorite candidates, because they're not spherical. But once you do, oh no, that's interesting. That's not the slide that I thought was coming next. So I'll come back to that. But basically, when you look at these things under a microscope, they are tiny. They would fit on the end of a cocktail stick, which is what that person is kind of poking around in there. And they are spherical. You get them, you take a look at them, you snap them, pictures. If you want to, you can send them off to John Larson and his team in little baggies, and they will analyze them for you and tell you whether you've got micrometeorites. I suspect they probably charge for that. How do we know that these rocks that we found, whether they are from Mars or from the moon, are from there? How do we know that they are not just bits of gravel that you might find, on someone's driveway? Well, we've been to Mars, we've been to the moon, and we've brought material back from from the moon, and we've analyzed material on the surface of Mars. Now, actually, in the last year or so, we've also brought back material from asteroids as well. We analyze that material and we end up getting a graph. It's called, we do a spectrographic analysis, and you get a spectrum or a range of all the different chemicals on a graph that are in that rock. And they did that. They've done that on Mars with the rovers and so on. They've done it with moon rocks and so on. So we've got a really good, solid idea about what these rocks look like and what they're made of. So if you find a meteorite and you submit it for testing, they will compare that information on the rock that you found to existing information that we've got from the moon and from Mars. And there's a very incredibly simplified graph there. So for example, any of the red bars, for example, look at sodium and potassium. They are very common Earth minerals, but they're not very common on the moon. Conversely, titanium and magnesium are very common on the moon, but not very common on Earth. So straight away, if you've got a rock with a bit of titanium and magnesium in it, not much potassium and sodium, then you've got a meteorite. If it's the other way around, then you've got a meteor wrong. Now, I think I might end that there, actually, because the last 2 slides are just specific to whatever particular meteor showers happen to be happening. If I give this talk on a night of a meteor shower, Then we talk about these are peaks in activity throughout the year. You can see kind of in May and June and the end of July there, we've got a couple of small meteors showers coming, but the next big one is the Perseid in August. Then you've got the Geminids in December. But basically from August through to January, that's kind of meteorite season, if you like. And if you want to go looking for shooting stars, because you can hunt for them and see them in the sky as well as looking for them on the ground, completely clear, no light pollution, no moon, and have great big fisheye lens eyeballs where you can see the whole sky at once. And if that's your conditions, then you will see your hundreds of shooting stars kind of per hour or two. Obviously, we normally get clouds. There's a bit of light pollution. Sometimes the moon's up and you can't scan the whole sky instantly at the same time. So the amount of shooting stars that you'll see on any given meteor shower is normally between a quarter and a third of what the zenith hourly rate is. But for some of them, that's still pretty good, actually. I'm just going to double check. I wonder where that other slide went. I must have put that on a different PowerPoint. I've got one slide where I've taken, not me actually, I've taken some pictures from a friend of mine who's taken pictures of micrometeorites under a microscope. But that's not on this PowerPoint, sorry. So there you go. Anyway, that's my presentation on shooting stars and meteorites. Doesn't normally take an hour, but we normally don't stop in the middle and show our actual space rocks to you. Tracy, that's a good omen that your birthday is on the 12th of August. It's like everything good happens then, doesn't it? If you've got any questions, please unmute yourself and fire them at me now. Danny, if you've got any questions, you can fire away as well.
I just want to say thank you first of all, because that was really interesting. I have followed John Larson on Twitter. I've been having a little look at those micrometeorites. They're amazing photos. They look like eyeballs, don't they?
Yeah, well, so that's why I wanted to show you the photos that I got downloaded from my friend the other day. And I think I've put them on a different PowerPoint for something else. So I'll have to bring them into this one. But they, down a normal microscope, they just look tiny and they're black and white, monochrome and so on. What he's done there is he's used some kind of scanning electron topography, something or other, and he's taken pictures at lots of different focal depths of the micrometeorite. So if you're talking about something that's a millimeter across, and he's taken a couple of dozen pictures at each of these different, like 0.1 of a millimeter and so on, and then he's used software to add them all together, all the really focused bits, and take out all the blurry bits. I mean, all credit to him and his colleagues. They've done a fantastic job. Yourself. Yeah, oh, that's a good point, Danny. Ask me questions in Welsh. Go on. But, don't. But do ask me questions in Welsh because there's a translator, isn't there?
Well, we do have Dareth, who is a very good translator. So Kerry has just said, thank you. You've been wanting to visit Basselstads for a while. I must try to get there this year. It's wonderful. I've been to the outside of it and I got the date wrong and nobody was there. So I see them on the outside.
So Alan and Simon, yes, I think you're possibly. There's been basically it's like a sonic boom, it's like a bang bang, and you might even also sometimes with some of the fireballs, you also sometimes hear a kind of a rumbling sound as well that goes with the bang bang. But there's also often if it's going bang or rumbling, there'll be a bright light. Normally when you see a shooting star, it's out of the corner of your eye, you look and it's gone. But the bigger fireballs, we had one, it was amazing. We were at the observatory. I was there working one night. And I went, oh, shooting star. Now, normally, by the time people are looking, because they're looking over there and you go, oh, shooting star, they look, it's gone. But this, we went, oh, shooting star. And it just flew above us overhead like that. And it popped and fizzed and crackled and got brighter and dimmer. And then it got to there. And just before it faded out, it broke up into several pieces, which curved down towards the earth. So that would have hit somewhere in the Scottish borders and in all the moorland and marshland up there. I'd have loved to have.
Scottish borders.
Yeah, I'd have loved to have got up there, but it would have lasted about 2 weeks and all the dreech, the rain in the river. If you're interested in books on meteorites, by the way, there's loads. These are my two favorites. They're oldies. This one I bought actually from America for $2 by postal order. Michelle Moret, Hunting for Stars. That's a really old, that's like considered the Bible for micrometeorites. And this is more of a coffee table book, Meteorites, by Alex Bevan and John DeLater. This is one, again, I had to buy from America. It's a bit more expensive than the other one. This is like $30–40. So these are, if you could find these books in secondhand shops, then they're great.
If say there was a comet again, like Neowise, would you expect to see more meteorites and meteors?
More shooting stars?
Yes. Would you expect to see more activity?
Well, I'd say just generally no, really, because it depends on where the comet is coming from and where it's going to. So when you look at the solar system, you've got the sun. So let's say this is the sun, and all of the planets orbit around almost as if they're rolling around on a plate. Basically, they roll around on a fixed plane. They orbit around on a fixed kind of level, flat, imaginary surface around the sun. But comets don't. They kind of a comet might come in from the top of the solar system and around the sun and then fly out the top again or out the bottom or somewhere like that. So for the path of the comet and the trail in the dust to first of all intersect at the 2 points as it goes through that plane where the Earth's orbit is, and in such a way that it leaves debris there, that's quite a rare and unusual event. Now, luckily, the solar systems have been around for 4.5 billion years, so that has happened, but only to the point now where there's about 4 or 5 really prominent shooting star meteor showers in the calendar. Remember that graph I showed you that had all the various like Perseids and everything on it? But the graph that showed the activity, that's how many regular meteor showers there are from 4.5 billion years worth of cometary and asteroidal kind of breakup activity. So it is quite rare.
Tracy has asked, are you looking forward to any comets, and are any due to come near us?
Yeah, well, I mean, in the last couple of years, more and more professional and amateur astronomers are spending much more time looking at what we call NEOs, or near Earth objects. There's one passing by nowish, actually, and it's gonna pass in between the moon and Earth. And actually, this object is going to pass closer to us than geostationary satellites. So it's going to come within the orbit of satellites. It's going to pass through the orbits of satellites. And there was one last year that we didn't know that it had gone past us until the day after. So it went past, and then as it went past us, it got lit up by the sun, and people, oh, look at that, that was a near miss. So yeah. So there's more and more stuff like that happening. More and more people are discovering comets. There's a couple of kind of potential comets coming in this next year, but maybe binocular objects or so on. Off the top of my head, I couldn't name them, but if you get yourself on Twitter and social media and whatnot, whenever they become visible or potentially visible, we always talk about them. So do follow us, people like me and Danny, on the Twitter, or if you hate Twitter, and your Facebook is better, actually.
Had another question, Roy, from Mark.
Yeah, I saw that. What's the minimum angle for a meteor to enter the atmosphere and survive? From Martin.
That's a very technical question, so I'm going to make you answer.
I don't know, Martin. I don't know, I'm afraid. But it's not just going to be the angle. There are 3 things that will tell you whether or not a meteor will survive to become a meteorite. The first is the initial mass of the object, because obviously if it's quite small, if it's anything up to about the size of a basketball, hardly any, if any, of it's going to survive to reach the Earth anyway. There is the initial speed that it's traveling as well. So if it's traveling really fast, then it's going to get really hot, a lot more energy, less likely to survive. And you're quite right about the angle. There's a couple of videos now on YouTube where in the day, people have seen shooting stars come into the Earth's atmosphere and then come through the atmosphere and then skip off the atmosphere, like if you're skimming stones on a pond, and kind of they skip off out back into space. That's a good question. I'm sorry, I don't know the answer.
I think that is the end of the questions. If anyone has got any other questions, please do ask. We'll keep the chat open for another 2 minutes. So get typing furiously if you do want to ask anything.
I'll turn this glaring light off above me again.
So when you talked about the one that's going to be a near miss and come into the orbit of satellites, is there a chance that satellites could get taken out by that?
Well, it's like anything in space. When you're talking about how big space is and how empty it is and how vast the distances are between even things like the Earth and the Moon, and how comparatively small the Earth and Moon are to that distance, then realistically speaking, you'd say no, there's no real chance. It's unlikely to happen. But then statisticians out there would say, oh, but unlikely means it's possible, it might happen.
And when I guess we look at things like Starlink that are sending 40,000 satellites up, the more satellites we send up, the more chance there is that something would get hit, I suppose.
Yeah, I mean, it's and hitting each other. There was a couple of weeks ago, one of the OneWeb constellation satellites almost hit one of the Starlink satellites.
Oh.
And the reason that they didn't hit each other was because somebody somewhere spotted it, did the calculations on the trajectory, and then sent them an email. They had to email each other to say, did you know this is happening? And then they did little adjustments with their thrusters and moved them out of each other's way. But these mega constellations, they're talking about putting tens of thousands of satellites up there, and it's nuts, it's insane, it's bonkers. It's John Barentine, the Dr. John Barentine, the IDA chap, who you and I know very well, recently published a paper on the fact that the increasing number of mega constellation satellites is scattering light back down to Earth, and it's actually causing light pollution, even though these things are quite high, and it's causing light pollution. They're going to be hitting each other and crashing into each other. I reckon that will happen in my lifetime when I'm 50. Yeah. So I'm quite old now, but I've still got a few years left, and I reckon that's going to happen in my lifetime. But the other thing is, how egotistical to be, like a billionaire tech wizard and just be launching these things into space. Every 2 weeks he launches 60 into space.
Yeah, without any global decision into the sky. We'll have to share.
Not talking to anybody about it. And it's all very like, we need to give the poor people internet, and that's a very white colonial savior attitude, like the poor people who live in these countries couldn't cobble together or build or develop their own infrastructure if they had the time and the energy, or if he helped them, if he helped them. Oh.
Yeah. He's admitted now as well that it won't be free internet, actually. He's like, oh, sorry, actually, it will be quite expensive.
Well, I mean, I know people, I've seen people online in places like the outback of Australia and in the middle of some of the prairies and deserts of America, looking at trying to get it in, and it's hundreds and hundreds of pounds. You may as well just get a satellite kind of phone thing. There's existing internet for people out there that's cheaper.
Yeah.
I've Googled those two questions. I can't find the answer in the brief little bit of time that we have.
Well, we haven't had any more questions, but we're getting
no, I noticed that.
So you must have covered everything very well. That's what I think of questions. Or you fill people's brains so much that there's no room left to think. That's what I like to do in my presentations.
I like to also talk really quickly, so if you get anything wrong, people don't have the time to go, hold on. What did you say there? No, I mean, basically when you talk about meteorites and shooting stars and so on, it's like a Pandora's box of knowledge. It's one of those things where I'm sure all of you have done it. You go onto Wikipedia to look at what are the types of meteorites, and then like 9 hours later you're still there reading scholarly articles on God knows what, and then 2 hours after that you're reading about the breeding habits of unicorns in Narnia. It's like this, the internet can take you off into such crazy kind of journeys. And in fact, today when I was preparing for this, I did myself a little cheat sheet because I wasn't quite sure myself if I had remembered things properly. So I scribbled down what I could remember just off the top of my head and double checked a few things, and then I tweaked that PowerPoint a little bit. I'm still not quite happy with it, but it's where do you draw the line? You know, I mean, I'm sure I could sit here and talk about this for a long, long time, and you could, and I'm sure there are people that would be like, "Yep, let's open a beer and let's go for it." But eventually, you have to stop, you have to pause, and people have to think, and they have to consider their place in the universe. They have to consider the fact that, you know, we have rocks from space that are older than anything else on Earth. I've got 3 rocks on my desk here that are older than anything else on Earth, and one of them contains material that comes from the creation of the solar system. You know, I can pick up and hold a piece of the moon in my hands. I can pick up a piece of the once hot, broiling, molten core of an asteroid, and you can do that too. You can just go and buy these things, or you can go out and look for them yourselves. And that's, for me, that's what I like, because these rocks connect us with space. You know, normally you'd stand under these dark skies and you'd look up and you'd be either overwhelmed or made speechless by what's up there, or you can take a piece of space in your hands and look at it and hold it. This moon rock, some people sniff it. I'm not going to do that for you now, but we've had people come to the observatory and sniff it, and one person licked it. However you want to connect with the universe, meteorites are a very good way of doing it.
Well, thanks very much, Roy.
Thank you, Danny. Thanks for having me.
Everyone else has learned a lot, as have I, tonight. So thank you so much for sharing your knowledge with us. For those of us in Wales, it's very clear tonight, so maybe we will get to see some meteorites. Yeah, I'll be out there trying to catch stuff, be like panning for gold.
Yeah, I still can't believe that family gave that away. And what I can't believe either, I mean, you go and buy carbonaceous chondrites anyway, just generic normal ones, you know, at that price point, if you wanted to buy 40 odd grams of it or whatever it was, it cost you £200,000.
Wow.
Now, the fact that, yeah, honestly, they're really insanely valuable and really delicate and very friable. And the fact that he had a picture of it on his driveway and he collected it up, and it's the first meteorite that's hit England for a while, that's where the £500,000 kind of comes from. I can't believe that not one of those scientists went, look, I know you said we can have it for free, but we're going to give you a little bit of money.
Yeah,
if you want to, you give it to charity. They should have done. But yeah, it's money from space. Get out there.
Yeah. Well,
run those magnets through your gutters. See what you find.
Yeah, that's what I'm going to go and do now. All right. Thank you very much, Roy, and thank you everyone for.
You're welcome. Thanks everybody.
And thanks everyone for celebrating International Dark Sky Week. I hope you've all really enjoyed. And follow us, Project Norse, on social media to look for our other events. We've been told in Wales we might be able to start outdoor events at the end of the month. So that's exciting.
Oh, good.
And maybe we'll get some actual real meetings soon. But I hope you all have a really good night, and I hope everyone gets lovely clear skies, and I hope it's filled with shooting stars tonight. So thank you very much. Thanks, Roy.
Bye, everybody. Thank you. Bye.